Okay, hello, my name's Richardson. I'm going to talk about my weather clock, which I've unfortunately just discovered that my real-time clock battery has just run out because I took it up to the Houses of Parliament last week, and it was the week before, and it was off the battery for a long time, and it has been today, so I fouled up somewhere. I should have checked it last night. Anyway, I have pictures and I have it partially showing. It's just showing the wrong time at the moment. So imagine that, full of weather. And I won't put it there because it's going to fall off. So, who am I? I started programming on Commodore VIC-20 a very long time ago. Anybody here know the VIC-20? Yeah, still got one at home somewhere up in my loft. Must get it out sometime, see whether it still works. Almost everything I know about computing, I've taught myself. I didn't do any computing courses at school or university. I just pick things up and learn myself. What I am is I'm actually a performance architect, which means I test the performance of computer systems, large-scale computer systems, ones with hundreds of thousands of clients on it. So currently testing a website that has got 500,000 clients on it, and got to make sure it works with those number of clients on, doing their typical work on the system. I am the co-organiser of CamJam. I am the writer of the CamJam EduKit worksheets. I originated the idea of Pi Wars, for which I actually designed and built all the courses for it. Started Pot Pie and Pints, and co-organised the last two birthday parties on behalf of the foundation with my colleague Mike here. So, right, the Pi clock, or the Pi weather clock. The clock displays predicted local weather in Potton for the next 12 hours. So I would show it nicely on here, but as I say, our real-time clock has given up. And as you can see there, it shows the time, the date, that first middle section there. I haven't got a pointer, so you've got that square block with yellow in it. That tells you what hour you are, the predicted for. So that one's showing up there between 3 and 6. It's got whether it's going to rain, so that's the umbrella. It's got the wind speed. That's in Beaufort scale, so that's scale force 4 Beaufort scale, which means it's a little breezy. You've got the top and the bottom, the low and high temperatures for that 3-hour period, and then you've got the actual weather as you're used to seeing on your weather maps. That just says it's quite cloudy. Underneath this section here, it shows the next sets of 3 hours. So this one just happens to be showing the same one as the top because that's just how it worked out for this picture. But then it shows the 6 till 9 and the 9 till 12, so you can see going forward what the weather's going to be like. So why did I do it? Well, I wanted to do a fun project. Mike and I last year and the beginning of this year, were extremely busy. We organised last September the September Jam. That was the last jam that Mike and I did. And unfortunately my father fell extremely ill around about the same time. So I spent about a month or so going to hospital and back. We then did EduKit 3, which I wrote the worksheets for. We then did Pi Wars, and then we did the Birthday Bash. So in about 6 months, 5-6 months, we did 2 big events and a big release and personal stuff. So we decided not to run any jams for a few months, and I decided to work on this because I wanted to actually do something instead of just watching everybody else doing everything and showing and telling. I also wanted to learn Python a lot better. Obviously I know some of it for the worksheets that I did for the EduKits. That's fairly basic Python. And I didn't know Python before I started writing those worksheets. So I wanted to learn a bit more. I also wanted to be able to go out onto the internet and get some information from the internet. So I used web APIs. And also my wife always wants to know what the weather's like, doesn't she? It's my daughter down here. So she wanted to know, so I designed this, and what I ended up doing actually was I learned Git, I learned a lot about Python, creating image canvases, multi-threading, using classes, using dictionaries. I did use web APIs, and I also learned some laser cutting. Brian, a friend of mine, he allowed me to go along to the Cambridge Makerspace, and I made the case out of laser cut acrylic there, as you can see, and 3D printing. So, the parts. It's got a Raspberry Pi 2 in it. That's the fastest Pi I could get to actually drive the software. Pi 3 is just too fast at this moment in time. They haven't actually changed the libraries to work with the 3. It's got an Adafruit RGB matrix hat and real-time clock. So the clock's not working today, so that's why you can't see it. It's got 2 Adafruit 64 by 32-bit RGB LED matrix displays. These are the really small 3mm pitch, very expensive screens, but they do make really nice displays. Couldn't go with anything less than the 64 by 64 because I've got 2 of them, one on top of the other, because basically it's just got so much information I wanted to display. It's got a high current power supply. These matrices do take a lot of power. That's my power supply. Sits under my desk at home. 3D printed a frame for it, so it's okay to touch. Just don't touch the in and out bits of where the electricity goes. 3mm perspex. It's frosted perspex, and hence why you have that sort of hazy look about that. 3D printed parts. Oh, I forgot to put on there. I've actually got a motion sensor on it. The motion sensor, basically the screen switches off when no one's in the room. Open the door, go into the room, sits in my study, and it lights up. It's just the idea was that it wasn't using electricity all that time. Unfortunately, just the way it works, it still uses it. That's the fault of the software. So, here's what it's showing, as I explained before. The time, date, forecast, current weather and next weathers, reporting period, min-max time, wind and rain, and the rain symbol actually turns to a snowball if it's snowing instead. That shows the rain actually in 0.5 millimeter sort of divisions, and it gets bigger and darker as you get more rain, so you can just tell, yeah, if you've got 1 or 2 lines on there, you may get rained on. Maybe, I don't know yet. But if you've got sort of about 10 lines, 20 lines, you're gonna get wet. Take an umbrella. So it just helps us before we go out. What's the weather likely to be doing? We're going to be cold, do we need to go? That sort of thing. So, a bit about the programming. One of the things I learned, a bit of Python I learned, was about dictionaries. They're really useful. You know, with a normal book dictionary, you open it up, you go and find a word, you find a definition. Basically, you've got exactly the same thing in Python. You set up your dictionary, you have a word or a symbol that you want to look up, and then you've got a load of information that is associated with that. So, for example, up here, you've got icon and you've got blank. And what this one dictionary I've actually got is the position of the weather icons within the weather image. So the icon is at 0, 8, 7, 15, so that's just a square in the top corner, because I do all the images, in fact everything that's on the screen is actually in a bitmap image. And I load that in and then I split it up using the dictionaries to define where the symbols are in each larger image. So instead of going through and trying to load each individual image, it's just a lot easier. Put one big one together and use these dictionaries to define where they are. Classes. Because I came from old school programming before object-oriented programming came in, and the work I did has always really been in C, Fortran and that sort of thing, but we didn't have classes at the time. And I never really got into it, because my work never needed it, and I was always too busy doing other things. So I wanted to learn about classes, about object-oriented programming. For those who don't know, and I'm not going to explain it very well because I still don't know it fantastically, is you define an object. This could be a glass, for example. And you can do certain things with glasses. You can fill them. You can empty them. So you write a class that is your glass object, and then you write some functions that you can do on those classes, some actions you can do, methods you can do on those classes. Empty it and fill it, that sort of thing. So you program that once and you say, right, I'll create this object, this class, and do stuff with it. But I want two glasses because I've got a friend coming round. Well, you just create another object. Same, everything does exactly the same to it. You've got two glasses, but you've only programmed it once, and you're just saying, right, I want a glass, I want another glass, and I want to be able to do this with it. So that's what basic understanding of my own of what classes are. I've found them really, really, really good. So in my clock, I have a weather class that goes out and gets the weather, and then other classes can actually go, and methods can say, right, well, what's the weather? And it goes and gets that from that object. I've got other ones that are canvases, that each part of the screen, this screen is one whole canvas, as I call it, and each of these is a separate canvas. So that I can update that canvas separately, and that canvas was then drawn onto the big canvas. So that's an object, that canvas, and I can draw onto it. That's an object, that's another canvas. Then the whole screen is a canvas, so I've actually got little canvases, which are little objects, drawing onto one big canvas, which is exactly the same definition of the object. It's just used to take all the other objects in, but they're all the same, all programmed with the same class. Not explaining that very well, but I just find them that they are really good to think, right, I've got this object, what do I want to be able to do with it, and just program that part, and then you can reuse it a number of times. Fantastic. Multi-threading. Well, each of these sections of the screen needs updating at different times. So it goes out and gets the weather about every quarter of an hour. I could get it every hour, could get it every 5 minutes. I'm using openweathermap.org. That allows me to do, I think it's about 100 requests an hour for free. I'm only doing about one every quarter of an hour, so I'm doing about 4. Just don't need it any more frequently than that. The time here, that is being updated every second, because you can see the flashing dots there. So that's updated every second. So every second it just checks, right, do I need to update myself? Yes, I'm an even second, I put the dots there. I'm an odd second, I don't put the dots there. And then minute goes past, it draws that thing. That up there, the date, it only that thread runs, and it sleeps for 24 hours. 24 hours later it wakes up and then updates the date. The main canvas, that's every, I think it's a quarter of an hour I get that one updated, because the weather doesn't change that often. So that just sits, and most of these things sit and wait and don't do an awful lot. Apart from that bottom section, which the objects are all, each of those objects that are in the bottom, that bottom weather section, those update every quarter of an hour. But I've got another thread that actually does the drawing of those, that weather, and that updates every 10 seconds or 20 seconds, and the cycles around that bottom weather. If only it was working, you'd be able to see it. So, and I've also got another one that detects a movement. And these are all running separately, all doing their own things in their own time. They don't have to wait for anything else. They just work on their own. So it's not like classic programming, you sit, you just run through, right, I want to run this, I want to run this, I want to run this, goes back to the top of the loop. Just doesn't work for this sort of thing, because you want it, all things happening at the same time. Image canvases, I've already mentioned some of those. Here's each section of the screen I've defined as a separate canvas. I'm drawing onto those canvases separately. It doesn't mean it's displayed yet. It's just held, it's just an image, it's just held in memory. And then it's only at certain times, so when something's updated, the main canvas, the main screen, says, right, I'm going to update now. I need to draw this image, this image, this image, this image, and this image on it. So Each object looks after its own canvas, and then one takes them all in. So it's you're not having to draw on the main image all the time. You can split things up. So it allows me to actually redefine what I'm going to put on the screen. I can, with the use of dictionaries that have all the definition of where everything everything is, I can say, right, well, I actually want to do have the maximum minimum somewhere totally different. Move that on in the dictionary. Each object that uses that dictionary, that'll move in it. I don't have to then go deep in the code and change, well, this is where the minute's going, this is where the second's going, this is where the clock's going. I just do it by changing dictionaries, and they're all picked up by the code, and it's all drawn separately on separate canvases. Okay, web APIs. OpenWeatherMap.org gives has some APIs that you can call. You can get the weather for every predicted every 3 hours, every day's prediction. You can go long term, 5 days, that sort of thing. You just call this API. You have to get your own special code that allows you to access that API. So you have to register with them, and it's free, and it's actually quite granular down to areas. So you just search in their database for the area that you live, and you can go and get the predicted weather for that. And it just comes down as either XML or it comes down as JSON. I'm actually using it as JSON because there are some libraries that will convert that JSON into Python lists. So I can then navigate those Python lists, get out the data I want, instead of just having to search JSON files. How long have I got? Not long. I'm meant to be my own timekeeper today. It doesn't work very well. Okay, I used Raspberry Pi. It's running headerless. It doesn't need much more than that really, because it's not doing a massive amount of stuff. I don't have to have a GUI on it or anything, because it just sits up on my wall, working for months on end, and it has been working months on end. I use PyCharm as my IDE. Brian was mentioning that. He uses the professional version. Sounds like I need to go and get that because it's got some nice things. I'm using the free version at the moment. I do all my Python coding in that. What I love about the PyCharm is it does syntax highlighting, and it does hints for styles and things like that. It really does help you with your program. But I do that all on my PC. I've got a nice 4K screen, so it's all nicely laid out instead of trying to squeeze it down onto a Pi screen. I then use WinSCP. As soon as I save the file, I use WinSCP. It zips them straight over to the Pi. I then got a terminal running, and I can then stop the program there while I'm testing it. So it's just a methodology I've worked out myself that I find quite useful. And all this code is stored on GitHub. So if you go to github.com/geekytim/pyclock, all my code's on there. It's not brilliant code, as I say, I'm teaching myself, but it's my code, and I do update it occasionally. I did update it so that it would actually work here with a, because it's not connected to the internet here, it actually gets the data from a file. The clock's not working, so it doesn't know what to get. It thinks it's January the 1st at the moment, but it hasn't got any weather for January the 1st. The file doesn't cover that. So I could get it working if I could LDP into it. I can then set the clock correctly and it'll work. I'll maybe do that outside. Okay. Any questions? Rough cost, Tim? 200, 250. Not cheap. The screens themselves are about £80 each. They're two 32 by 64 LED, RGB LED displays made of fruit. Then there's the card that drives it. That can drive about 6 of those screens. That's about £20. There's a Pi 2, £30. The laser cutting, the power supply, 3D printing. So yeah, about 200, 250-ish. So it wasn't a cheap project. I knew it wasn't going to be, but it was something I really wanted to do. I mean, I'd been planning it for about a year. I've got the parts for over a year before I actually finished the project, but never got the time because I do silly things like run jams and finals and parties and things like that. So yeah. Any more?
How long did it take?
Oh, sorry.
Sorry.
How long did it take me? A good question. From start to finish, probably about a year and a half, because as I say, I didn't do very much in it for a long time because I had the idea and started designing it and just ran out of time. But from, I suppose I must have started it around about March, April time this this year.
So when
Yes, it is this year.
When you started to look at finding weather, I was intrigued to find that you went out and found a free.
Yes, I believe in open source.
Yeah.
But I do believe also in supporting them by giving them money if it warrants it as well. But I looked at quite a few different ones. BBC, they had one. I think they still got one. There are a few others that are based in America and that sort of thing, but this one was just ideal because it came down every 3 hours, it updated, and I could go local, and it was in the right format for me. So I just went out and looked at a lot, and the main thing that I had to do was find whether there was Python code that would get it for me.
So did you look for that weather before you started your project? Or did it come as?
It basically, as I was putting things together, I said, right, what elements do I need? Part of it was drawing on the screen, so I spent a bit of time doing that. Part of it, I knew I could get weather from out there, it was just where to get it from. So I started some of the programming, then I said, right, I actually need to get my weather now. And I need to know what format and what sort of information I can get. Yeah. So that was sort of the next major part, was actually having decided to do was, okay, let's get some weather. What can I get? What do I need to display on the screen? So I spent a few nights browsing the internet, finding code and seeing what I could find. So yeah, so it started, must have been about March, April this year, ended about May, June. So it didn't actually take a massive amount of time. Still got more work I want to do in it. I want to change the display, it's showing a lot at the moment, I could change it. But then I'm using dictionaries, so I can change it quite easily to find things. Any other questions? I think it was one. Yeah?
So you've got a motion sensor on there?
Sorry?
So you've got a motion sensor on there?
Yes, I do.
Is that behind the perspex as well?
No, it's just sitting just outside the perspex there. Had a little hole cut in. I've got one of those small detectors. There are a couple you can get. That was actually one of my biggest issues. Actually, was the motion detector because I was actually finding when the motion detector said, right, well, there's no movement. I then programmed it to switch off the screen. Screen switched off, which made the motion detector say there was movement. So the screen came back on again. There was something with the hat that actually was causing the GPIO pin to go high when I was clearing the screen. So what I've actually done now is it doesn't stop the screen from drawing, it just doesn't draw anything. So it's blank basically, hence why I said it's on all the time, unfortunately. And the CPU is actually running around 100% all the time. I can't get it any less than that, and it's only running on one CPU out of the 4. Python multi-threading has only got it on a single core. That's what I've found so far. It should go on more, shouldn't it? What have I done wrong?
It's the way the Python interpreter works.
Thank you. Thought so. Yes, I want it running on all 4 cores, which is why I chose Pi2. Any more questions?
Really quick one.
Yes.
The 2 screens you've got.
Yes.
If you haven't got access to laser cut perspex, could you just use it with the 2 screens?
Oh yeah. Yeah, you just need to wear sunglasses.
So incredibly bright.
They are incredibly bright.
So the perspex is really to protect your eyes.
Pretty much, yeah. It did hurt my eyes when I was developing it without the perspex. I had to find something in my garage to cover it up so I could actually see. Yes, I suppose I could turn things down a bit, but there's a limit. When you're turning some things down, you don't want to turn everything down. It's just works. Light's just gone out. That means I'm probably out of time, I suppose. Oh no, that was you, Matt. Okay, any other questions before I run out of... I have run out of time.
You have these people who overrun their talk.
Oh, I know, Jim.
Shocking and
Yeah,
disgrace.
yeah. Any more quick questions since Jim's here? Okay, thanks very much.